is in the form f of x is equal to b raised to x, where b should be greater than 0 and b should not be equal to 1. Why so? Remember that 0 raised to any number is just 0, and 1 raised to any number is just 1, right? Now, for the properties of exponential functions, we have our domain. It is the set of all real numbers. So in interval notation, you will write it as negative infinity to positive infinity. And for the range, it is the set of all real numbers greater than 0, or it is the set of all positive real numbers. Why so? So wait, for in the interval notation, we will write it as 0 to positive infinity. Now why so? Why is that? Why is our range is 0 to positive infinity? So it says here that our graph should land on quadratic 1 and quadratic 2. Remember, our range is the values for y, right? And as you notice, the y here starts at 0 up until positive infinity. 0 to positive infinity. Yan. So that's why our range is 0 to positive infinity. Okay. Now for the y-intercept, we have 0, 1. Therefore, our graph will always passes through the point 0, 1. Because b raised to 0 is always 1, right? So therefore, our y-intercept is 0, 1. Now, for the x-intercept, we do not have x-intercept. And for the horizontal asymptote, it will always be x equals to 0, or simply our x-axis. Okay, now let's have an example here. We have f of x is equal to 2 raised to x. So first, let's give values for this function. So x, then y. It's better to have 5 points to have somehow precise points on a graph. So we have 0, -1, then -2, then 1 and 2. You can also use just -1, 0, and 1 if that's only the required points. But if the instruction said that you should have 5 points, then you should consider having 0, -1, -2, 1, and 2 as your points. Okay? Now, to get the function, the value of the function, or the y, we just gonna substitute the x to the x here. Y, or our f of x. So first we have -2 as our x. So y is equal to 2 raised to -2. That is what? Remember reciprocal. That is 1/4, right? 2 raised to 2. 2 raised to -2 is 1 over 4. Just get the reciprocal, then square by the positive exponent. Then we have y is equal to 2 raised to negative 1. That is just the reciprocal of 2. Then we'll have positive exponent. What about 0? We all know that any number raised to 0 is just 1. Right? So, 0, 1. Wait, let me fix this. Then 1/2, and then 1, and then 0. Okay, for a while. Okay, let's just... Okay, so y is equal to 2 raised to 1 is just 2, right? Then y equals to 2 raised to 2 is 4. Right? So, if we're going to graph that, we will have this. Here, we will have this graph. Okay? Now, what is our domain here? Our domain. Remember, our domain here is all real numbers. So, negative infinity to positive infinity. Now, our range here is 0 to positive infinity. 0 to positive infinity. What is our y-intercept? Remember, our y-intercept is just 0, 1. Because anything raised to 0 is always equals to 1. So, here's our y-intercept. Y-intercept is 0, 1. Then, what is our horizontal asymptote? We can see here that our graph approaches 0. 0 here for a while. 0, but it never touches 0. Right? So, our horizontal asymptote is y equals to 0. Now, as you notice, our graph here increases from left to right because our b, which is the 2, is greater than 1. Therefore, our graph here is an example of exponential growth.